Okay, welcome and good afternoon, everybody. You have joined the NASA Earthdata webinar, Data Albums, an event-specific data discovery and access tool. This is your host, Jennifer Brennan. While everybody's logging in, we do have two polls at the bottom left and middle of your page that I'd like you to take a moment to answer, if you would. But we do have 2 p.m. Eastern Standard Time, so let's go ahead and get started. What I'd like to do first is go over a few housekeeping items related to this webinar. First, to ensure best audio experience, the conference has been placed in silent mode. However, if you have any issues or questions, what you should do is enter them into the Q&A pod, and you will find that on the right-hand side of your screen, and this works like a chat. Okay? The webinar itself will be recorded and posted not only to our Earthdata Adobe Connect catalog as well as to our NASA Earthdata YouTube channel. The URLs will be provided on the contact slide at the end. All presentation files will also be available for download at the end of the webinar. Okay, the webinar itself is 1 hour long. 45 minutes are allocated to the presentation and demonstration portion, with another 15 minutes for the question and answer period. After our speakers have finished their presentations, what we'll do next is we'll move to a final set of polling questions. And then after that, we'll move to our question and answer period. So that will come directly after your final polling questions. As I mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar, with the exception of the demo portion. And again, you will do this by using the Q&A pod located on the right-hand side of your screen. Questions will not be answered using the raising hand function. It has been disabled. Again, we'll take all questions using the Q&A pod at the end. One final note, depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who wish to stay on the line. Okay, what I'd like to do next, let's move to our agenda. Okay? And during the first 10 minutes or so, our first speaker, Ken Kaiser, will provide you with an overview and also the motivation for the NASA Data Albums project. During the next 25 minutes or so, we'll switch speakers and move to a detailed technical description for Data Album's search and discovery tool, and then also the demonstration. It is my pleasure to introduce our first speaker today, Ken Kaiser, who is a research scientist at the NASA Global Hydrology Resource Center Distributed Active Archive Center, or the GHRC DAAC. Ken?
Thanks, Jennifer. And good afternoon or good morning to everyone. We appreciate the opportunity to present information about our data album project. This is an ongoing effort, although we are reaching the end of the funded project. Hopefully in this session we can explain the technology and demonstrate why and how it can be useful to researchers and others. This project has been funded by the NASA Access Program. The lead institution is the Information Technology and Systems Center at the University of Alabama in Huntsville. As you can see on the slide, we had a PI change on this project when Rahul made the transition from UAH to NASA. But he has obviously stayed very involved with this ongoing effort through his role as the GHRC DAAC manager. Sarah Graves took over as the UAH PI, and a number of other UAH staff and students have been involved with the design, development, and testing of this technology. The science use cases have been very important for this project to help drive the requirements and development direction. Scott Braun and Brad Zavotsky have been instrumental in guiding our way to hopefully useful functionality for science researchers. As an outline of this presentation, this slide lists the main topics we will be covering. We will transition from the slide presentation for a recorded demonstration of a current data album implementation a little bit later on. Events are the driver for the creation of a data album. In a nutshell, a data album is an aggregation of data, information, tools, and services, all combined in a container that can stand alone for interactive investigation and analysis. But an album can also be used to transport or convey event-based data and information to other applications and systems. The drivers for this research and development of data albums included the amount of time and effort expended pulling together data and information in response or as a reaction to an event. The challenge typically is not only finding the data sets of interest, but also determining the relevance of the data for the specific type of event and for a particular event occurrence. For instance, if you are studying processes involved with hurricanes, you are likely interested in data sets that provide measurements of properties like wind speed, precipitation, pressure, and so on. That information is not always obvious from the name or high-level description of a data set. Beyond the content relevance of data sets is the temporal and spatial relevance, as in which files cover the time and location of the event of interest. And once you've found the right data, then finding analysis and visualization tools that are compatible can sometimes be another hurdle. These are all aspects that drove the development of data albums. There are several important features or innovations that are pulled together through the data album concept. First, as mentioned before, is the aggregation of multiple, often disparate types of data, all targeted and relevant to the specific event. An album handles the discovery of the data and in most cases provides the links or tools to access the data as well, providing a fairly comprehensive package of relevant information. The structure of this aggregation functionality has been generalized where possible to make it more easily extensible or adaptable to other types of events or uses. The filtering of data and information for relevance to the specific event is really the key to the value of the data album. There is still more work to be done in this area, but the implementations we present here, we have made some good progress with filtering the information based on space, time, and context to focus in on the more relevant items. The value of this capability is obvious, and we plan to continue refining the functionality. We have explored some ways to display the data and information in more interesting and hopefully useful ways to help users more quickly interpret the information. In many cases, as we will show a little bit later, the albums provide multiple ways to display and interact with the same information so users can choose the presentation that works best for them. Everyone has their preferences on how they perceive information, and we are still working on finding the best fits for the intended science users. The analytics dashboard that Ajinki will demo is an example of providing some quick analysis tools to aid in the user's ability to use the available information in an event to help decide what event or events are most interest, refining their targeted albums based on an event statistics and related information. The high-level architecture diagram shows the main parts involved with the generation of an album. At the bottom are some example data sources. Included in the data layer are services that read the various types of data and filter them based on relevance to an event, such as time, space, and event context. We have a service layer above the data that is used when generating an album for a specific event, thereby populating the information in the album. The presentation layer provides all the visible gadgets into the various types of data for the event. An album is curated. This process may be executed repeatedly for some time period to update the album with the latest and most complete information. Otherwise, an album would just be a snapshot in time. They are most useful when updated, curating the aggregate information. This is an evolving component. We have been experimenting with algorithms to rank data relevance, primarily science data, based on an event-specific ontology. We've had mixed success in this area. Working with the science teams, we can build pretty good ontologies for the different types of events. For instance, hurricanes that we will look at next. But where this approach breaks down is in the quality of the metadata in the various science repositories. If the metadata is not complete or correct, then automated relevance analysis is not very successful. This is an area of continued research that is branching out from the Data Albums project to look more closely into these issues. We have the benefit of quite a bit of hurricane and severe storm research being conducted here at UAH and the Marshall Space Flight Center. Although we are a little bit removed geographically from the impact of hurricanes, our Global Hydrology Resource Center, the GHRC DAAC, participates and supports NASA and NOAA hurricane field campaigns. We also work with the NASA Short-Term Prediction and Research Transition Center, SPORT, located here at the NSSTC, a consortium of UAH and NASA, along with the Huntsville National Weather Service, both of which have an obvious interest in severe storms. These associations help drive the initial data albums prototypes that we have deployed. At this point, Ajinkya is going to take over and explain and demonstrate our current albums and some of the underlying technologies.
Okay, thank you, Ken. I'd like to now introduce our second speaker today, Ajinkya Kulkarni, who is a research software engineer at the NASA Global Hydrology Resource Center, DAAC. Ajinkya?
Thank you, Jennifer. Now I will like to talk about the hurricane deployment and walk you through the various components of it. Afterwards, I will show you the demonstration. Then we will look into severe storm deployment as well. While the hurricane albums are generated as soon as we receive alerts for new storm, they are better suited for curation as historical albums, since researchers are likely to be interested in the aggregation of information after the event. Severe storm deployment is more of a near real-time activity. This slide shows an interactive analytics capability in data albums where the user can display and compare information about all historical hurricanes using multiple variables. Another analytics capability that we have in data album is called box plot. Box plot lets user view groups of data based on quartiles, which is a convenient way to identify outliers in the data. We are providing a number of ways to select the hurricane of interest, but the most straightforward way is the table view, which lists all the storms for each year, color-coded by the maximum intensity category for each storm. The Sunbus interface groups the categories of storms for each year and uses the angle size of the storm to reflect the storm's duration. This is a quick way to find a type or level of storm of interest, but it might not be the most intuitive if you are just looking for a particular storm in a particular year. Then the table view is the most direct way to select a storm. The bubble chart view is yet another way to group a year's storms by category and represent duration. Once a storm is identified, The album for that selected storm is displayed with all the information content from the various data sources. The data and information displayed on this page have been filtered for relevance to the targeted storm. We display the storm statistics pulled from NOAA reports along with a general information description of the storm which is pulled from Wikipedia. Multimedia content relevant to the selected storm are listed, such as YouTube videos and other images. The relevance filters are using temporal and contextual comparisons for these contents. The storm track view has options to display the track either overlain on the Moody's data for each day corresponding with the selected storm's track, which can be animated to step through each day's images, or a map view displaying the track. The point on the track is selectable with metadata about the storm at that point, displaying wind speed, pressure, category, and location. We provide a couple of ways to get to the relevant science datasets, either through a table view with faceted search filters or a sunburst arrangement indicating rankings of data collection relevance based on the event ontology. The data granules are further filtered based on temporal and spatial relevance to the storm track. Links to the data granules are provided so the user can access and directly download the files. Now we will move to the recorded demonstration of the data album. We are now looking at data album's hurricane instance. This instance is publicly available at the URL shown, and I will provide you links to this instance at the end of the presentation. We are now looking at an overview page of the data album's hurricane instance. This page is divided into two sections. The first section is the analytics section, and the second one is storm search section. Now moving into the analytics section, we have two views. The first one is the interactive chart view. The second one is box plot. In the interactive chart view, we can compare storms using multiple variables simultaneously. For example, here on the y-axis we have average pressure, on the x-axis we have maximum pressure selected. For color, we are using maximum wind speed, and we are using storm length for the size of the storms. And at the bottom we have slider where we can select a year. We can of course select different parameters and compare storms as we like, and the chart will update instantly. Now moving into box plot view. Box plot lets us view groups of data based on quartiles, which is a convenient way to identify outliers in the data. We can select different parameters for box plots such as pressure, maximum sustained wind speed, and storm duration. Once we make a selection, the chart will update instantly. we have drill to months option which groups the data by months in the selected year. If we deselect it, we get data for all the years. We can download these plots as PNGs for offline analysis. Now moving into a storm search section, we have three views to identify a storm of interest. The first one is table view, the second one is bubble chart, and the third one is sunburst. In the table view, we show all the storms available in the catalog all at once. The color of a storm cell represents the highest Saffir-Simpson wind category of that particular storm. Now moving into a bubble chart view, bubble chart view groups the storms by their highest Saffir-Simpson hurricane wind category. Here, the color of a circle represents the highest Saffir-Simpson category of a particular storm, and the size depends on its storm duration. We can select any other year and get the storms in that year. Now moving into the sunburst view. The sunburst view lets us compare multiple storms simultaneously using the highest Saffir-Simpson hurricane wind category and storm duration. Here, the color of a storm is based on its highest Saffir-Simpson hurricane wind category, and the angle of the storm represents its duration. We can zoom into a specific year by double-clicking on the year, and then we get all the storms only in that year, hiding all other storms. We can go back to previous display by double-clicking on the circle in the center. The sunburst view provides us facets which let us add or remove storms from the sunburst chart. For example, here I can add 2011 year in the sunburst. We also provide legend for the Saffir-Simpson hurricane wind scale. Once a storm of interest is identified, we can view the data album for that storm by just clicking on the storm name. And we can do that from any of the three views that we just saw. Once we click on a hurricane, we are taken to the interactive album for that hurricane. Here we are looking at the interactive album for Sandy, which occurred in year 2012. On this page, we have three sections. The first one is storm statistics and multimedia, the second one is map display, and the third one is data access. In the storm statistics and multimedia section, we pull the description of the storm from the Wikipedia. We pull the storm statistics from the NOAA storm summaries, and we pull YouTube videos as well. We can click on the video and it will be played in the same window. We can also navigate through rest of the multimedia using keyboard shortcuts. Now moving into a storm track section, we have here two views. First one is the MODIS map and second one is the classic map. In the MODIS map, at the bottom of the map we have a strip which has days from the hurricane storm track. We can zoom to get more detailed imagery of the MODIS data. Here the red arrow indicates the day which is currently selected. We also provide detailed information about each track point, which includes information such as date, location, wind, type, and pressure. We can select another day to get MODIS imagery for that day. We also have option to cycle through all the days automatically. Once we click the play button, the MODIS imagery for each day will be pulled and shown as an animation. We also have a layer switcher which allows us to deselect different layers available. Now moving into the classic map, here we are overlaying storm track on a more familiar Google Maps view. Here also we can get information about each track point. Now moving into data access section, here we have two views. The first one is table view, the second one is sunbus view. Here we display the most relevant data sets for the selected storm. Once we select a storm, we get the list of data granules available for that particular data set. The sunbus view categorizes the data sets either by keywords or instruments. Here the color of the data sets depends on its rank and the size depends on the number of granules available. We can adjust the relevance to refine the dataset list. We can do similar for the sunbus view as well. As we refine, we get more or less datasets depends on the current threshold. Once we identified a dataset of interest, we can select it and get the granules for that particular dataset. Either we can get links to all granules or we can select individual granules and get only those links which can be downloaded for offline analysis. Now we will move to the slides and I will talk about the data albums severe storm deployment. As mentioned earlier, the severe storm deployment is targeting more of a daily real-time activity to collect information about ongoing severe weather outbreaks across the country. Because it is a more timely activity, we are able to incorporate more short duration information sources such as social media content that is only available briefly. We have been working with the NASA Sports Center on the details of these albums with the idea of providing resources to researchers in severe weather topics. At the moment, we initiate the selection of these albums by displaying the distribution of severe weather activities such as wind, hail, and tornado on a yearly, monthly, and daily basis. The user is able to graphically see the relative intensity of storms by the year, then drill down into months of the year, and finally into a specific day of a month. Selection of a day then takes the user to the severe weather album contents for that day. This slide shows an event page with aggregated and filtered information from various sources. I will talk about each of these components individually in next slides. When severe activity alerts are received, we access the National Weather Service convective outlooks for the day so we can capture what was predicted. This can be useful later to verify what was known before the activity got started. We also capture the pertinent watches for the day, which is also helpful post-event to see what features the weather service was focusing on and when. The mesosphere discussion captures chat-type correspondence among the weather researchers who are commenting as situations develop, providing insight as to what they were seeing and how they were interpreting things. The National Weather Service also issues public severe weather outlooks, and those are captured as well. Outside the official channels, the album also captures and filters information from a variety of social media forums such as YouTube for videos, Flickr for photos, and Twitter for text information. As mentioned before, the refinement of the relevance filtering of these sources is an ongoing activity. But we are already able to capture some definitely relevant information. Scientists we are working with value the social media content as it can be used to help validate their observational data of the severe weather features such as, did this radar observed tornado actually touch down? Or was there damage sustained from this wind event, etc. As with the hurricane albums, we also identify science data sets that are relevant for the severe weather events and then provide links to granules that meet the temporal and spatial filter for the target event. In these albums, we are prototyping the ability to provide interactive visualization of the data granules and some simple image analysis capability as well. This is an ongoing effort. Now moving into the deployment of these albums, we chose to employ Docker technology for the data albums deployment for a couple of reasons. Initially, some of the technologies we were using for the albums implementation were not deemed secure enough to turn loose on our servers. Also, we had some dependency requirements that were not compatible with our current server configurations. By releasing the deployments within the Docker virtual containers, we essentially isolated the functionality from the rest of the server, avoiding the compatibility issues while at the same time protecting the native server. An additional benefit is that we can easily save the deployed Docker image for redeployment on the other machine or at other sites. The Docker technology is continuing to improve, and we think it is going to continue to be a useful tool for these and other kind of implementations. Hopefully, the data album technology is useful to enough science research areas that we will be able to continue improving and evolving the capabilities. We plan to integrate the album technology with our event-driven data delivery infrastructure to provide a pre-event context for the comprehensive discovery of relevant information and the transportable packaging of the data. We appreciate the opportunity to present information about our data albums project. This is an ongoing project, although we are reaching the end of the NASA Access funded effort. We hope that in this session, we were able to explain the technology and get the point across of why it can be useful to researchers and other users. We are providing the links to two data album deployments here. We encourage you all to use and play with these deployments and give us your valuable feedback and suggestions for further improvements. The Hurricane deployment is the most stable and is in production, while the Severe Storm is currently in the beta state and not yet ready for wide release. Thank you.
Okay, thank you, Ajinkya, and thank you, everybody. What we'll do next is we will move to the final set of polling questions. I will give these just a couple of minutes or so, and then after that, we will finish up with the Q&A portion of this webinar. So please be sure to stay in the room and or stay on the line to participate in the questions and answer period. Thank you. So we'll give this a couple minutes here. All right, thanks. Okay, we'll give the polls just another minute or so, and then we'll move along to the question and answer. Okay, everybody, what I'd like to do now is go ahead and move to the question and answer period. However, since I see that there's a question built into one of our polling questions, I'd like to go ahead and address that first, and then we'll move to our log of questions that have been asked so far, okay? The first question is, Ajinkya and Ken, how static are these? And that's related to the use case examples question. Can you think of other use cases that might benefit from a data album approach? And the question is again, how static are these? Could users upload a list of times, locations, or is it all hand-built? Is it full of links or of manually assembled data? So either one of you two, I leave it to you, answer this question.
This is Ken. I think I'll take that one. The albums are not static in the sense that they're generated based on an event occurrence. So let's look at the Hurricane E example, for instance, that's watching through some tools when the hurricane alerts are issued that generates the album for that storm. And it's going out dynamically and pulling that information into that album. They're static in the sense that then we have that catalog of those albums that are generated so users can browse back through that catalog to get to those albums. They're not manually generated at all. The data is all programmatically pulled into the albums based on the sources of information and the relevance ranking of the different data. Hopefully that answers the question. Oh, and so because of that, part of the question was, can you upload times and locations? Not in the current version, because we're basing it on the space and time of a particular storm to go out and get that information. So it's driven by that event itself.
Okay, thank you, Ken. So one of the questions actually came very early on, and the question was, how can I use this for my scientific work? So it's a very general question,
but... Yeah, the feedback we've gotten from the science users we've been working with is that they feel it's important to be able to go back and find, for instance, if you're studying a particular storm or a particular day of severe weather, to go out and find all of the information relevant to that particular activity. So that's really the emphasis of what we're trying to do with the albums in these two particular prototypes, is to gather all of the disparate information about an event or a storm into one container. So then the researcher has all of that at their fingertips when they come back to use it. And I think that's the answer.
All right, thank you, Ken. So before I move to the next questions, I just wanted to make a quick note that the presentation files for today's webinar are located in the lower right-hand corner of your screen in the file sharing pod. You've got the presentation, the agenda, as well as the recorded demo. And to download those files, you would highlight it with your cursor, and you'll be able to, download those files. Also, that will be a persistent feature for the recordings. After the fact, you'll be able to still download. So just really quickly, I wanted to mention that to the participants. And then your next question, Ken and Ajinkya, is, are these maps that are created, can they be downloaded as .kml files that can be used in Google Earth?
Yes, we actually have API that generates the KML, and that we use ourselves to plot the storm track. And yes, they can be downloaded.
Okay, thank you, Ajinkya. And I had a couple of questions myself as I was listening as a communications lead as well as this host. I think that the cool is very, very cool. And I guess my first question is, when you were retrieving the MODIS imagery, was this tapping into the NASA Worldview tool and the MODIS? It's not really MODIS rapid response so much since we're talking about storms that have already passed, but I was just curious about that.
Yes, we use the API from the tool that you mentioned, the Worldview.
Worldview, okay.
Yes.
Great, okay. And I had a couple of more. And then when the relevant data products results are displayed, are those being pulled from the entire archive as available through ECHO?
Yes, that's correct. We pull from echo and then we filter using spatial and temporal, values.
Okay, great. And then my final question, and then there are some more questions. And in part, you kind of answered this earlier. Are the data products available for download in formats other than HDF or HDF EOS? And I guess the question is that dependent upon the product, or within this interface, do you have an opportunity? I know I noticed the FTP links to download in different formats.
Right. For the science data, at the moment, it's only available whatever form the repository is making the data available in.
Okay. Okay, thank you. The next, okay, so the next is more so of a comment. It said, fascinating idea and capability, needs time to sink in. Cool is the word. Sorry, I have to go. So any other questions from anybody? Don't be shy.
And we certainly will appreciate any feedback that people would like to get to us directly as well. That would be useful.
So actually, I do have one more question while we're hopefully waiting for someone else to type in a question here. When might the severe storms deployment go prime time or be released from beta stage? Did you guys have like a estimated time frame for that, or?
Yeah, I think we're probably a couple months away from being ready to release that for prime time. Our activities most recently have been focused on getting the hurricane version into operational state.
Sure.
There's a lot more facets to the severe storm and a lot more interaction we need to have with the science team, exactly how to slice and dice that to make it useful.
Sure. Any other questions for our speakers today? Let me take a look, make sure I haven't missed any. Any other questions? So it doesn't look like we have any further questions. And so what I will do, that will conclude this webinar. And what I will do next is, log off from the telecon, but I will leave the meeting room itself, this, online space open for another 10 minutes or so for those of you who might be interested in downloading the presentations. I don't have, and just to put a plug in for our next webinar, I don't have it up, a meeting announcement put up there yet, but I will in the next week or so. It will be a land processes oriented webinar, and we're going to feature our LPDAC to disk tool. So that's an interesting capability. So be looking for that at the tinyurl.com, Earthdata webinar. You can sign up to receive announcements for upcoming webinars. We have a mailing list listed there. We also will be posting this this recording to our NASA Earthdata YouTube channel. So we've got about 20 or 22 of them already. You can check us out if you search for NASA Earthdata with a capital E, and just search on YouTube, and follow us on Twitter at NASA Earthdata. And of course, GHRC, they also have a Facebook account. And what is that? It's GHRC DAAC, guys? Is that right? And then also a Twitter account at GHRC DAAC. So if you want to hear some, climate and severe storm related news and events and data or tool updates, you could check them out there. All right, well, thanks everybody. I'm going to go ahead and log off the telecon. There you go, great. Thank you, Tammy. And we'll keep the room open for a few minutes. Thanks so much for joining us today. I hope to see you.